Hello viewers, this is Aileen Sonia Das, working as Assistant Professor in RMD Engineering College. So last class, we had seen from the subject Air Pollution and Control Engineering, we had seen about absorption principle. So in this video, we will see about adsorption principle. So adsorption is a process where gases, vapors or liquids are concentrated on a solid surface as a result of surface or chemical force. The amount of adsorbed substances depends directly on the internal surface area of solid and the kinetics of the process. So in the last video itself, I had compared absorption with adsorption. So adsorption is nothing but the gaseous pollutants comes in contact with a solid adsorbent. So the absorbents can be bauxite, activated carbon, activated alumina, silica gel and molecular sieves. So it depends upon what type of contaminant to be removed. Depending upon that, the adsorbent will be chosen. So in this video, we will be seeing about activated carbon as an example for adsorption. Since activated carbon will be used for removing contaminants present in gas. That is mainly for removing odors and also for contaminants. So generally, gas adsorption, it can be either physical phenomenon or chemical or biochemical phenomenon. So physical phenomenon, it depends upon the temperature and pressure conditions, and chemical adsorption depends on the reactivity of the gases and their bond forming capacity with the surface of the absorbents. So activated carbon is used to purify liquids and gases in a variety of applications, including municipal drinking water, food and beverage processing, odor removal, industry. It is also known by other names such as charcoal. So, what is the difference between carbon and activated carbon? So, activated carbon is just nothing but it is a form of carbon processed to have small, low volume pores that increase the surface area available for adsorption or chemical reactions. So that the contaminants, so more the quantity of the contaminants, amount of quantity of the adsorption efficiency will be higher. So that's why we are going for activated carbon. So the various forms of activated carbon, powder, granular, pellets, and here how it is reaching that stage from coconut shell to coconut shell charcoal, and from there to granulated, and from there granular stage to powdered stage. So already in the last video we had seen the difference between adsorption and adsorption. So I said adsorption, the gaseous contaminants adheres to the surface of the adsorbent, whereas in adsorption the gaseous contaminant gets absorbed by the absorbent. So the various absorbents used in solid form to remove these gaseous pollutants. So here we have, if you need to remove SO2, the absorbents used will be pulverized limestone or dolomite, alkalized alumina. And if you need to remove the gaseous pollutant like H2S, adsorbent used will be iron oxide. If HF, it will be lump limestone, porous sodium chloride pellets. Or 99 nitrous compounds, silica gel will be used. organic solvent vapousness, activated carbon will be used. Design of carbon absorber depends on total volume of gases to be purified and amount of pollutants present. A common design of the absorber is shown, where the gases are passed from below the activated carbon bed contained in a vertical chamber. So here we can see where and all activated carbon absorber can be used. It is more suitable for removing odorous organic compounds such as methyl chloroform from the film processing plant, isopropyl alcohol from a citrus fruit processing plant, vapors of ethyl alcohol from whiskey warehouse, cleaning of kitchen exhaust, mercaptans, and butyric acid, etc. The activated carbon beds last for a few weeks to several months before they are to be replaced. So this vapor absorption by activated carbon occurs in two stages. So the two stages are adsorption stage and saturation stage. So adsorption stage will be that stage where the carbon absorbs the vapor actively. But a stage is reached in which the carbon continues to absorb but at decreasing rate. Saturation stage. During this process, a point is reached when vapor concentration equals to that of the inlet. This means that the carbon is saturated and it has absorbed the maximum amount of vapor at a given temperature and pressure. This saturation value is different for each carbon and vapor. So you can see in this diagram, the polluted gas enters through this inlet. So through this space provided, the polluted gas enters and passes through this activated carbon absorber. So the remaining clean gas will be sent outside. The gas flows through an activated carbon bed that traps the VOC chemical on a surface. Various types of activated carbon are often used in absorption systems. The carbon is thermally or chemically activated with the object of providing area. One way of considering carbon's potential is to consider that 1 pound of carbon, a large surface has more than 100 acres of surface, which enables activated carbon to have the tremendous ability to absorb certain VOCs, that is, volatile organic compounds. Initially, for carbon absorber system design, isotherms are studied for particular volatile organic compounds. Other considerations include air volume, pressure, elevation, relative humidity, temperature, and the potential effects of multiple compounds in the airstream. Adsorption is a heat-sensitive and relative humidity-sensitive process. Additional considerations in the process design are particulate oils or other contaminants that may exhibit the prohibit the carbon from absorbing volatile organic compounds at optimal rates. There are several types of carbon absorbers, with the most commonly used being fixed beds and fluid bed absorbers. Thank you for watching this video.